of the questions is to figure out which is the template that you are supposed to copy and paste. Okay? All right, so question 3. We are trying to compare the number of red light violators, the week before and the week after the red light cameras were installed. Can you reject the hypothesis that mu before minus mu after is less than or equal to 3 and alpha equals 0.025 in terms of after minus before? What is the type of this question? Do you have equivariance?
No.
You don't have equivariance. Are those two samples are dependent? Yes. Why they are dependent?
Because it's the same thing.
Well, what does dependent samples mean? What is the definition of dependent? Well, here's the definition of dependent. If the same thing with the same person are acted upon twice.
Action
Twice. Then these two samples are dependent. In this case, we have the week before and the week after. So these 2 weeks are independent. They're not dependent. Right? Remember, we are given a sample on the packet. I don't remember the exact page. It is saying that we're trying to test the same 8 peaks, right, with brand A and brand B. Right? So in that question, we're trying to test the same 8 peaks twice, right? So that tells me we are in dependent samples. However, in this question, the week before and the week after are not dependent. Doesn't make sense. Well, in question 5, this 2 in question 5, can you conclude the average weekly sales of this razor in supermarkets that have a video advertisement is greater than the weekly average sales that do not have a video advertisement? Right here, this is the alright. Why I said these 2 are dependent? Because we are trying to test the same razors, right? The same razors twice. The first time we were trying to test the weekly average sales if we have a video advertisement, right? And the second test is whatever we do not have a video advertisement. But the thing that we are testing is the same. Right? So the same razor is tested twice. That is why we say, in this case, in question 5, we have a dependent sample scenario. Question 3. So my HO is mu after minus mu before, mu after minus mu before. Because the order is after minus before. After minus before. Well, if I change the order, then what is the sign in my HO? Because previously I have mu before minus mu after, and that is less than or equal to 3. Now, yep.
I'm still confused as to how that's not dependent because isn't the same like lights? It says in the question that it has the same intersection.
Because the original poll was the, what is yesterday, you made us come to the top.
Well, what we're testing is 2 single wigs, right? The wig that we have a red light camera and the wig we don't have. So those 2 wigs are independent.
But it's still the same intersections. It says a select set of intersections.
But we do not have a specific thing or person that are acted upon twice.
He doesn't need it.
Well,
Because
yes, I mean, it's not
One
easy
week
to
is-
identify independent and
1
dependent.
week is camera.
Yeah, but question
And then
3,
1
No
week is
camera.
no camera.
Yes.
the thing that we're focusing on is those 2 weeks. We're not focusing on, we're focusing on the number that the week before and the week after. We're focusing on the number before and after the red light camera installed. All right, so I'm given mu b minus mu a is less than or equal to 3. However, my real order is mu a minus mu b. Then what is the sign in my HO? I need to multiply the -1 on both sides. And how's my sign? If I multiply a negative number on both sides of this inequality, then I should change the direction of the sign. So I have mu a minus mu b is greater than or equal to -3. So if the order is after minus before, then my hypothesis value is -3. Let's go to the Excel template. All right, so in question 3, you were supposed to copy and paste this. Houston, Anderson, Antonio. Why this is the one that I am supposed to follow this? Because in this case, I'm given the scary DF. 14 is the scary DF, which is right here. The formula for my scary DF is here. And that tells me I have a scary DF, which is 14 in this table. Copy and paste. Houston and San Antonio. This one. This one, Houston and San Antonio. Copy and paste. Yeah, that is for question 3. The first one. So what I'm supposed to do is remove the lower tail and upper tail. Lower tail and upper tail. And upper tail. What is the width for each column? I have at list 47 for column E, at list 15 for the rest of the columns. I have 47. Do I have 47? Yes, I have 47. 17, yes, greater than 17. Okay, you good? Yep. Alright, so what is my T crypt? Since I have a lower tail pass, then I have a negative T crypt. Alright, so before I go to my T table to find my T crypt, I have to have the DF, which is the lower tail and upper tail is right here. Lower and upper. Yep. Alright. My scary DF in this case is 35. Right? Oh, here's the reason we choose this template. Well, the first thing is we don't have any equivariance assumption, right? The second thing is we have to identify if these two samples are independent or dependent, right? In this case, they are independent. They are independent. Maybe at 35, my alpha is 0 to 5. 35.025. I have negative 2.030. Alright. So this is my T crypt. So my decision rule is if my T stat is less than negative 2.03, then I will reject it. This is my decision rule. It's in row 35 with an alpha of 0.025. Yep. All right, step 4. What is my test statistic? Yep. It's given right here. So we should change the hypothesis value right here in the green cell to negative 3. Because my hypothesis value is negative 3, not positive 3. All right. So if my hypothesis value is negative 3, then my test statistic is this guy. So I still reference, which is this one. What is my coefficient? 84%.
Let's see.
84. So this is my test statistic, which is not less than negative 2.03, so we fail to reject. So we fail to reject. Sure. because it asked me to state a hypothesis in terms of after minus before. Yeah. So this is the previous HO, and it asked me to switch the order from there to here. Mu A minus mu B. Fail to reject, there is no significant evidence to conclude mu A minus mu after minus mu before is less than -3. Now, step 7, what is my p-value? Well, before you get your p-value, let's see where my t-stat is. My t-stat is positive 2.2979. My t-crit is negative 2.03. So by definition of p-value, the area that I'm going to highlight is right here. And that is a large area, right? And that is a large area. What I'm given in this chart, in this table, is the p-value for two-tailed test. So if I'm given the p-value for two-tailed test, how can I have the p-value for a large area?
1 minus.
Yes, I divide the p-value for two-tailed test and subtract it from 1. Exactly. So one minus the p-value for two-tailed test divided by 2. Right? 1 minus F28 over 2. F28 is the p-value for two-tailed test. We divide that guy by 2, which is the p-value for one-tailed test. Right? Since it's very small, let's try it. We can double check it. If I divide this guy by 2, I got 0.01, which is a very small area, right? And that is not the answer for my case. I have to subtract that small area from 1 to get this large area. After minus before, okay, this before minus after. Okay, so you were asked to find 84% confidence interval in terms of after minus before. But you are only given the confidence interval in terms of before minus after. How can I do that? Did you mention it? Yes. We flip it, we switch it, we flip it, but after that we have to add a negative sign, right? So my lower limit in terms of before minus after is my upper limit in terms of after minus before. But we have to add a negative sign, right? So if I add a negative sign in front of my lower limit in terms of before my after, I got positive 149. If I add a negative sign right there, I got negative 7.86. Now, this is my new upper limit in terms of after minus before. So my lower end point is negative the previous upper limit in terms of before minus after. My new upper end point in terms of after minus before is